Okay, can you give me the question?
Yeah, sketch the continuous time interval xt is equal to 2 t minus 1 u t minus 1 minus 2 t minus 2 u t minus 2 plus 2 t minus 3 u t minus 3.
Want me to show you a picture?
Are you not writing it down?
Yeah, because you want me to show you how to do it, you need to tell me the question. I cannot memorize it. Okay, so
I'm gonna write it up there for you.
okay, so what's the first term?
2 t minus 1
2
t minus 1
t minus 1
versus u.
times u t minus 1.
Yep.
Then
Minus 2 t minus 2.
t u t t minus 2.
No. You just want to look at it. You just want to look at it. I got it right here.
Yeah, okay, good. Okay, so the minus 2 ut minus 2 ut minus 2 and plus 2 u on the top, right? On the top, right?
Yeah, the top one.
Minus 2t minus 2 ut minus 2, then plus 2t minus 3 and ut minus 3, right? Anyone knows how to do this? Anyone has done it? Okay, what is t times u? What is t times ut? That is RT, right? So t times ut, that is RT. Yeah? RT is like that, right? T times ut is 1 and t is greater than 0, so just same thing, right? Alright, so this one means that is 2RT minus 1. And this one is 2RT minus 2. And this one is 2RT minus 3.
Right? Is that because you multiply them by the first number?
Yeah, this one is RT equals T times UT, right?
Yeah.
So this is good. Then you delay by 1 time. So this is T minus 1. Then ut minus 1, you delay by 1 time. So that means you delay by 1 time, so t minus 1. Okay? You delay by 2, you delay by 3, so that's something. Okay? Okay, so now you know how to do this, right? So the first one is RT, but delayed at t equals 1. So this is 1. And the amplitude equals 2. So this 1 here, this 2 like here. So this is 2, and it must be here. So that's the first term all the way like that. Yes? Right? Now this one is at t equals 2. So this is 2, 1, 2. And at this point, it will here, then you bend down by 2, so it will go like this way. This one is gone, so we have this. The first term go all the way to this. The second term, up to this point, if I do it together, this is the first term. The second term starts from t equals 2, but going down like this. So these two terms add up together give us a level. Right? So just like this. And all the way up to 3. Yeah? After 3, we need to change again. 3 is 3. This is this plus RT minus 3. So then we up again, like this.
So what did the two constants be?
This two?
Yeah.
You mean this two or this two? This two, right?
That two, yeah.
Front, okay. This two, look here. RT means this is 1, this is 1. So this is RT. How about the 2R? This is R, this is RT. How about the 2RT? 2RT means when t equals 1, this one will be equals to 2. Will be here. This one. So this is RT. And this one is 2RT. So just 2 is the slope.
I see. You
just
have it like that up there, I got it.
yeah, the slope increases from 1 to 2.
Gotcha.
Right? This clear?
Could you do C2? Could I trouble you for that one?
Which one?
C is the next one. You won't get it too.
Oh, this one, you use the same concept, but you need to play a little bit. Right? Look at here. The key here must be the same, so that means by delay by some. But this is the first one, right? The second one is t plus 1 ut minus 1. So I only discussed the first term for you, right? So this one, we like this, that is okay, right? This one is only, see, delayed. But there's t here. If delayed by 1, this one must be t minus 1. Okay? So we are going to write this one as t minus 1, ut minus 1 first. This is what we want. See, this one equals this. But that is t plus 1. We write t minus 1. So actually this one is t minus 1, then plus 2. Right? T minus 1 plus 2 equals t plus 1. So this here equals this. Then I copy this one. So that's why equal, right? T plus 1 equals t minus 1. That is what I like. Then plus 2. Because I need plus 2 so to make sure they are equal. Okay, now I distributive. So this one I consider as one term. So t minus 1 times ut minus 1 here. Then this one to this. Then plus 2 ut minus 1. It's good?
No.
Now what is this? This is rt minus 1. And this one is 2 ut minus 1. So you can plot this, you can plot this. Right? This one is just the RT delay by 1 time. And this one will be UT delay by 1 time. Then the amplitude will change to 2 instead of 1. So if I draw only this term, right? So you have 3 terms add up together, but for this one here, what I have is this is 0, this is 1, so I will go 1, so this is 2 here, this is 1. So make sure this is R1, RT minus 1, right? That is this up to this point, like this. Then you need to add it to this. Add to this. This is T minus 1, so it will be at, that's 2. So that's 2 here, 3 here, this one. So this one will be gone, then this one will shift this one. So the curve will be this and this. Right? But this is only for the first term. When you do this, actually you do not need to draw this first term first. You need to combine all these 3 terms together. Then it won't be like this weird. Right? Any other question? Good. Okay, last time we discussed the output of a LTI system. Right? That means if we have an LTI system, linear time invariant, right? And this one, right? So I have LTI here. The LTI system is represented by an impulse response. So suppose that is HT. Right? Impulse response means when the input is an impulse, the output will be equals ht. So when the input is an impulse, the output will be ht. So that is called impulse response. And now if we have an input xt, so that is the output of LTI system. Output of LTI system. This one will be yt. And we know how to calculate this. This one is just xt star ht. Anyone still remember what does this star mean?
Convolution.
Convolution. Right? That means xt convolute with ht. Still remember the definition for this one, the convolution. I posted the lecture notes, so you need to review and preview. Right? So this one here equals an integral from negative infinity to positive infinity. Not positive infinity, to t. Right? From negative infinity to t, to the present time. And x tau and ht minus tau, then d tau. That's the definition of a convolution. Later time we can prove that this one also equal to this one here equals h tau t convolute with h. So these two can switch position. Right? This is also equal to this. That means this one will be equal to h tau convolute times x t minus tau, then d tau. Right? Either way, x convolute with h equals h convolute with x. I will erase this first, then we just use this one. So how to do this? I give you two signals. How to calculate the convolution of these two signals? Steps. Step 1. Step 1. We are given xt and ht, so we can draw this. But we are going to draw plot x tau and h tau. Here given ht, xt, we draw this one. So in terms of tau, not t. That does not change anything, right? So for example, you can draw y equals x squared, or you can draw y equals t squared. That's the same thing. So this one is x, this one is t. They have the same curve, right? You just change the variable, so that's no big deal. Right? So you just replace t with tau. So that is the first step. Right? So now we get x tau, we get h tau. So we have x tau and we have h tau. We already draw this two. Here is okay, x tau is good because this is x tau. But what we want is ht minus tau. So what we do is we flip this with respect to y-axis. So we get h minus tau. Right? The step 2 is flip or mirror, no matter what, to h tau. We have h negative tau. So you have a curve like this, then you flip with respect to y-axis. You get this one. It's good? Okay, the next step is, look at here. What we want is the output when at t. So for example, what is the output when t equals 10 seconds? So that means this t is known, right? What is the output when t equals 1 second? So this t is, we know that. So that t is known. The integral is only to with respect to tau. Right? So this one we know this. That means we are going to shift. Here we are going to shift this one. So if we mirror this only, that means this one equals, I can put a 0 minus tau here. Negative tau equals 0 minus tau. That means this is the t, so t equals 0. Although I do not put the t here, but because it is 0, that means t equals 0, so the t equals 0. If you give me other t, for example, you ask t equals when t equals 10 seconds, then I will change this one to 10 seconds. That means I need to shift this one. So next one is shift h negative tau to h t minus tau by t times to the right. So this one I will write better. Okay, to the right. Get t minus tau. So now we have a x tau here, and we have a ht minus tau. So we have this, we get this, we flip this, then we shift this to the right by t. We know t, right? Then we multiply these two. Step 4 is multiply x tau with h t minus tau. Multiply these two. Then the last step is do the integral. Integrate. Then you get the result. That is how we derive these steps from the definition. Then next time we are going to discuss in detail how to do this with an example. Any question on this? It's good? Okay, now let's discuss an example. The example is xt equals ut minus 2 ut minus 1 plus ut minus 2. That is x. Another signal is vt. This one equals ut minus ut minus 1. I want to do the convolution of these two signals, xt and ut, and vt. How to do this? Step 1. We need to draw these signals, right? So the step 1, we draw these signals. What is the xt? So this one is t. This one here. ut is 1, like this, all the way to the right. And minus 2 ut minus 1, so that it will be 1 here, then it will give us back this. Then at t equals 2, we add up, so that is what we have. So that is xt. Question? You already know how to plot this, right? In homework, we practice this in homework number 1. So what is the vt? Vt is the same thing here. So ut, like this, and minus ut minus 1. So this is 1. So this is vt. And this amplitude equals 1 here. So this is t. Questions? Okay, what's next? We said we plot the x tau and h tau. That means these two signals in terms of tau. Here we plot t. So we can just replace t with tau. Right? Okay. So I will change this one into a tau, and change this one here into a tau, change this one here into a tau, and change this one here also into a tau. You don't need to change anything others, the waveforms, all the same. Just change this variable. So now we have x tau and v tau. Good? That's step one. So this is step one. We plot this. What's the next step? We need to flip one of these two. Which one you want to flip? So you can flip anyone because we already said both ways work. So for example, I flip this one. I will here. Okay, let me redraw this. So that is, this is x tau, and the v tau is like this. What we want is v negative tau, right? Can you draw v negative tau? Just this one flip to the side, right? So it will look like this. What's this number here? -1, this is 1. So this is v, I will put v negative tau. From here to get this. Yes? But that means this one is 0, right? So I can put a 0 here. Right? So I get this 2. I don't have space, so I will. Now we have this. It's x tau and v t minus tau, but in this case only t equal to 0. The next one is we need to shift to the right by t time. So we need to consider. For example, the first one is if t is less, this one t equals 0, right? I will put this one after this one here. So make this one better. So this one is v 0 minus tau. So it will look like this, -1. I move this one to here, right? Just same thing, right? The reason is you can see this clearly. Right? So this is tau, this is tau. Or I can draw with this. It's good? When you do this, you also need to better to align this. Right? Right? The first one is this one here. This keep in mind this is t, right? So when t equal to 0, we need to multiply these two signals, then do the integration. So while t, which equals 0, equals integration from negative infinity to 0 to t, this signal multiplied by this signal. What is it? This signal multiplied this signal. At this time, this one is 1, but this one equals 0, right? So this one multiplied at this point, you get nothing. How about this point? This one 1, this one equals 0 here, so nothing. How about this one? How about at 0? Right? 0, this is 1, this is 1, so you get only 1. How about when tau equals here? What is the multiplication? 0, 0, because this one equals 0, this one not is 0, still 0. Right? So actually this signal multiplied by this one, what we get is only 1 at tau equal to 0. That's a single point. But you do the integration for the single point, what we get? Get nothing, right? Right, so we just set this one, the tau, then you get nothing. Does this make sense? These two signals multiplied together, what you have? These two signals multiplied together, what you get is this one. Is only this signal, like this, right? You don't have anything this way, you don't have anything this way. You only have 1 at tau equal to 0.
Okay.
Then you do the integration from negative infinity all the way to here. What you have? The integration means we find the area, right? What's the area of this line? Nothing. Because this rectangle, the height is equal to 1, the width equal to 0, so nothing. So that's why we get this. It's good? Okay, now, how about if t is less than 0? T less than 0 means this here is to the left, right? Yes? So that means this window is at here. Then you multiply this window with this one. What do you get? Same thing, 0, right? Right? So that means we can write this one less than or equal to 0. Because these two signals have no overlap. That means they multiply together, they get 0. Then you do the integration, still get 0. Yes? Okay, now let's do the second one. I shift this t to, for example, t is greater than 0, but less than 1 or equal to 1. Right? This signal is just this window, right? So now that's t equal to 0, the right edge at this point. I shift to the right, okay, so this t equals 0.1, then 0.2, 0.3, okay, 0.5 here, and the maximum is, okay, t equals 1. T equals 1, that one will be, okay, so this is gone. T equals 1, it will be like this, right? If t equals 0.5, it will be, look like this. We shift this signal to the right by 0.1 second, then the signal will look like this, right? So this signal multiplied by this signal, what do we have? From this point to 0, we have nothing. From 0 to this point, this is 1, this is 1. So we only get something like this one. That's the only part we have. So the result will be equals to just like this. Make sense? Yes?
Which step was that?
This window at the beginning, when t equal to 0, it is here. Right? Suppose this is the window, right? So like this one here. We shift to the right by t. And t is within this range. For example, if t equals 0.5, means I shift this one to the right by 0.5. So the window will be slide to this point. Right? This is when t equals 0.5. When t equals 1, this one will be equal to completely at this point. Can you imagine this? Right? So now we think, because this t is within this range, so for example, t is here. So what is this point? This point is t, right? Keep in mind, t is between 0 and 1. Now this signal multiplied by this signal, what do we have? Before this part, we have 1 here, but we have nothing here. So that result equal to 0. Yes? And from here to here, this equals 1. This one equals 1. 1 times 1 equals 1. This equals 1. But this one only extends from 0 to t here. After this t, we don't have anything in this part. Although we have something here, multiply, we get nothing. So this signal is the product. It's good?
So is that the convolution?
No, not yet. We just calculate the product yet. We still need to do the integration, then we find the result. Make sense? So this is the product. Now we need to do the integration from all the way to negative infinity to t. So this one here, yt, will be equal to from negative infinity to t. What is the value, the product here? The product equals 1, right? This one equals 1. So it is 1 d tau. Yes? From negative infinity, we don't need to care, right? From negative infinity here, we have nothing. So we just change this one to 0. Or usually you should copy this, right? So yeah, you can just use 0, or you can just rewrite, copy another. This is just from 0, right? Because the integration is from negative infinity to t, from here to t. All this part is nothing. So you just from 0 to t. This is 0, this is to t. Good? Questions? You multiply, you get the result of these two signals, then you integrate the product. The product is 1. This is 1. This 1 times 1 equals 1. But we need to determine the range. The lower range is 0. The upper range is t. So the integration is from 0 to t.
So how is the first one not negative 1 to t? How is the first one not negative 1 to t?
This one? What?
The first one. Yeah, both that.
Which one? This one?
Yes. How is that not negative 1 to t?
Negative 1 to t. Because this one, when t is less than 0, this window is here. Right? So look, this signal when we flip, that is at this point. That means the t equal to 0. It is at here like this. If t is less than 0, that means this window will be to the left. And you multiply this one with this one, you get nothing. The whole range is nothing, is 0. So no matter where you integrate, it's 0.
Gotcha.
So you still get 0. Everybody clear? Alright, so this one is somewhere here like this, then this is a product. And we just need to integrate out this part from 0 to t because we don't need to care others. Others is nothing. Alright, what is this? Huh? This one equals t, right? That is in Math 169. 1 d tau equals tau. And from 0 to t. So that is t minus 0 equals t. Does it make sense? Okay, now let's draw the output. Right? So the output will be I draw, okay, we don't need this anymore, right? So I will draw at this point. So the output will be here. Output is a function of time, and this is time. When t is less than 0 or equal to 0, what is the output? 0. Here, that is our output. And when t is less than or equal to 1, that is just the t. T is RT, right? Right? So means when t equals 0, the output equals 0. When t equals 1, the output equals 1, equals t. Right? So it will be here. This is equals 1, and in between, that is a straight line, right? Oh, that is output looks like this. Question? That is mathematical representation. This is our graphical. Right? Before t equals 0, we don't have anything. Between 0 and 1, the output is just the t. So when t equals 0, that equals 0. When t equals 1, that equals 1. When t equals 0.5, that equals 0.5. When t equals 0.8, equals 0.8. So that is a linear straight line. Right? Slope equals 1 because y equals t. Slope equals 1. Yes or no? Yes? Okay, good. Is this clear? No? Which part?
Why? How you got it?
How we get this or how we get this one. So you need, see here, you need to determine this one. You need to determine this one.
Yeah, I know you got it right.
You need to determine this one. Then you use math to do the integrate. So which part is not clear? This 0 is good because before that we have nothing. So you don't need to write a negative infinity. So that's why we start from 0. Okay? Why this is t? Because you shift this one to t, so the t is here. And this one is before this one. So the right edge is t. That's why it's t. Right? Then why this is 1? Because this is the product. The product means this signal multiplied by this signal. So you can see this here, we have nothing, so this one is gone. This part is nothing, so multiplied by this part is gone, because it's 0. So what we have is only this part, which gives us this one. And this amplitude here equals 1, this one equals 1, so 1 times 1 equals 1. So that's why you get 1 here. Good? Now the next step is just the integration. So 1 d tau equals tau. Right? Tau, then replace tau with t on the top, then minus replace tau with 0 on the bottom, so t minus 0 equals t. Is this clear? Better? Everybody needs to be clear. This one will be definitely in the test. I can tell you like this. If you want to apply for graduate school, engineering or anything, they are going to test you, for example, signal systems. If there's only one question, that is this. So you know this is important, right? Convolution, that's the new concept. It's so important that if I ask you one concept, that is this one.
So that right there is convolution, which is
This is the result of the convolution, but only after this point. We haven't finished yet. It's good? Okay, now we need to continue going, right? Going to the right. So this one is t less than. Okay, the next one is whether t is greater than 1, but less than 2. So that means this window here past the 1. When t equals 1, this one looks like this, right?
Where are you getting these intervals at? Do we use the same intervals for every problem, or?
What do you mean?
So.
The integral is applied to the product.
Okay, I'm saying is I use arbitrarily big intervals on the.
Not arbitrary. The integral is from all the way to the present time. but you need to determine what is the integrate. The integrate not necessarily all this way, so you don't need to actually integrate all the area, the range. You need only integrate the one that has non-zero integrate, right? So you need to determine the lower bound, the upper bound, and also this one. All right, so this, when t equal to 1, this one is like this, right? So we know this equals 1, so that's we got 1 here. How about when t is greater than 1, less than 2? That means this one continues shifting to the right, like here, for example. Right? This t equals 1.5. I just use the example. You need to imagine this one keep shifting from 1 to the 2. Right? The right edge, 1 is here, then 2 up here. So this one is right in the middle, for example. Yes? So is this clear what we are doing? This means when we shift to a t, where the t is between 1 and 0, 1 and 2. So this one will be 2, like this. What's next step? Multiply, right? We multiply this signal with this one. Well, let's see what we have. This one here equals 1. This one here equals t. What this value?
0.
It's between.
This one here is t. This one is 1. What is this value?
0.5.
Huh?
Is it 0.5?
No, 0.5 is just one example. This one can be anywhere. Okay? Can be like here, like this. Can be like this. So this is t. Okay? So for example, it can be like this one here, like this. This is t. This t is from 1 to 2. 2 is here. This 1 is here. This t is between this one. So you just slide this one, pass this one, then before this 2, anywhere in between 1 and 2. For example, t is here. What is it? I don't know. Maybe 1.1, 1.2, or maybe, right? Any value between 1 and 2. I just represent it with a t. What is this value? T minus 1. Why? Because this width equals 1, right? The width of this signal is 1. So this is t, then this part must be t minus 1. Yeah? Hello? This is 1, t. The width of this window is 1. So this is t, then this is t minus 1. Right? So here, this is t minus 1. Okay, this one multiplied by this. On the top, that is 1. This is all 1. So between, so what's the result? The result is must be like from here to here, right? Because this is the only window that is non-zero. Outside the window equals 0. So we don't care this, we don't care this. So the result can only be within this range, but not necessarily equal to this, but within this range. It must be within this range. All others must be 0. This is good? So from this t minus 1 to this 1, this is 1, this is 1. So 1 times 1 equals 1. Alright, so that is good. We have this one. How about from 1 to t? This is 1. What is this?
1.
From 1 is here, right? From 1 to t, what is this value? Negative 1.
Negative 1.
What is this? 1.
0.
Multiply.
1.
1 times negative 1
Negative 1.
equals negative 1. So this one actually is not like this. It must be like negative 1, like this. So negative 1. So where is the range? From 1 to t, the value equals negative 1. Is this clear? Okay. Now, what is y? Do the integration of this product. Theoretically, from negative infinity. We don't need to start from there, right? Because all other part equals 0. So where is the, because we have 1 and negative 1, so we need to separate these two parts. So we have integration of this part, then integration of this part. So now the first part. The lower bound is t minus 1. So from t minus 1 to where? To this part, because this is 1. So from t minus 1 to where? To 1, right? To 1. And the function is what? Is 1. Okay, and that's the top. Okay, then we need to plus another part, the second part. From where? From 1 to where? To t. What's the function? Negative 1. Perfect. Negative 1. Then the top. So we determine the lower bound, upper bound, and the integrand. Then the next part is trivial. Right? I assume everybody can do the integration. Right? So that's why we will, so this one equals t, right? It's tau 1 t minus 1, so that will be 1 minus t, then there's 2. So this part equals 2 minus t. Right? And this one is negative 1, so it's t, so 1 minus t. Right? So this add up together, so 3 minus 2t. So this result equals 3 minus 2t. You do by yourself, right? That's easiest integration in the world. Right? Integrate only 1. So the result equals 3 minus 2t. Where t is between 1 and 2. Let's see. When t equals 1, what's the output? 1. Oh, that is here. When t equals 2, what is the output? Negative 1. Okay, so 2 is here. Negative 1 is here. How about what's in between?
3.
This is a straight line, right? Is this straight line? The slope equals negative 2. The y-intercept equals 3. So this is a straight line. Right? So in between, just a straight line. From 1 to negative 1.
So if it doesn't have a U in it, it's a ramp. If it doesn't have like a U nowhere in the problem, you just use ramps the whole time.
Which part?
No, I'm saying like, for example, like you don't, for how you draw it straight down, you don't have to use like a unit step, you just use a unit ramp.
Yeah, because this line, obviously this is a straight line. This function means a straight line. If you want to try, for example, what is when t equal to 1.5? That is 0, right? That's it. 1.5 equals 0 here. How about t equals 1.6? Oh, that's negative 0.2, right? So negative 0.2 is here. So you draw this, this must be straight line. So you only need to draw 2 points, starting point and the ending point, then you know this line looks like this. Okay, looks this. Then the next step is, for example, t is greater than 2, but less than 3. Right? So we don't need this anymore here. Right? We already know how to do it. So when t is greater than 2, that means this function will be, right? So look, this is 1, this is 2. Right? T equals 0 looks like this, right? T equals 0. T equals 1, t equals 2 is here. So when t equals 2, that window looks like overlap completely with this one. Yeah? So this is t equals 0. Then t equals 1, t equals 2. Right? So we are interested in t greater than 2. So this window will be like somewhere here. And this one here is t. But it will pass 2. Right? T is greater than 2. You slide this thing to the right at t, which is greater than 2 and less than 3. It will be somewhere like this. It's good? This one here, the right edge is t. What's the left edge? T minus 1, because the width of the window still equals 1. And this one here equals 2. Right? Now, these two signals multiply together, what we have? We have only, this window will give us a non-zero, right? Possibly. All others must be equal to 0. So it will be looks like only this part. All to the right, to the left must be equal to 0. That's the maximum value we can get from here, right? All others must be equal to 0 because this window here. Now let's see what is the inside from t. This is t minus 1. This one is t. What is from here to, for example, to 2? What is from here to here? This one equals 1, right? What is this? Negative 1. So 1 times negative 1 equals negative 1. So actually this value is like this. So negative 1 here. From negative t minus 1 to 2. Eh? From 2 to t, what is that? From 2 to t.
That's going to be 0.
Is 0, right? Because we don't have anything here. So this one equals 0. So this is the result. This is the product of this signal with this one. Okay? We do the integration. What is the lower bound?
Lower bound is going to be t minus 1.
T minus 1. What's the upper bound?
Negative 1. No, I forgot what it was.
Look at the product. This is not very clear. Okay, so 2, right? Only from here to here, right? So 2. What is the function? What's the product?
Negative 1.
Negative 1. D tau. Right? What's this? This one will be equals to tau from t minus 1 to 2. Right? So that will be t minus 3.
T minus 3.
Right? This one is negative tau, right? Negative 1 d tau integral negative tau. Right? Then from 2 to t minus 1. Right? So we can change this one to positive, then switch the position of this one. Right? The same thing. So that means this is t minus 1, and this is minus 2. So t minus 1, then minus 2. T minus 3. Yes? Right? So this one equals t minus 3. Good? Okay. T minus 3, let's draw this. When t equals 2, what is it? Negative 1. Oh, it's here. When t equals 3, so t equals 3 here equals 0. In between, that is a line. So, it looks like this. Right? That is a line, the slope equals 1, so it goes up. When t equals 2 equals negative 1, and t equals 3, that equals 0, so like this. Good? Are we done? Not yet. We can still have this part, right? Okay, the next one is how about t greater than 3? T greater than 3, that means Okay, your window will be somewhere here, right? So can you tell me what the output is? Huh? 0. Perfect. Everybody can see why it is 0? Because your the product equals 0. This one times this, they both have no overlap. This part is non-zero, but this one equals 0. This part is non-zero, but this one is 0. So you multiply, get nothing. So you don't even need to integrate. Right? If you want to integrate, okay, yt equals somewhere 0, just like this one. So you just can write just 0. Right? Like 0, that means like this. So that's the convolution process. How do you feel?
Not very good.
I know you need to practice. Okay?
So you said this is the only question that's on the test?
On the homework, on the test, or anywhere. If you tell somebody you study the signals and systems, they are going to ask you this.
So like if you, it's like future, like you be needed like for intern signal, so like during internship.
If you have a
Clear understanding about like signals, fundamentals, you need this for like interns, like a job.
usually this one has a very fundamental the concept. This one is just the technique how to evaluate this. The most important part is, for example, why you want to do this convolution? What's the meaning of this one? First one, you need to know how to do convolution. That is just how we do this, right? Now, why you want to do this? For example, you want to do multiplication. First one, you need to know how to do multiplication. Then, why you want to do that? You need to solve problems. For example, each day you get $3. Now you have 1 week. How many dollars you get? 3 times 7. So you need to know you use 3 times 7 equals 21. Then you need to know how to evaluate 3 times 7. This is the same thing. This is how I tell you to do the convolution. You need to know how to do this. Later time you need to know when to use the convolution. Why you want to use convolution instead of just multiplication or something else? You need this one. The convolution concept is very important. Why is it important? Because if we have an LTI system, if we know the impulse response of the system, you give me any input xt. What is the output? The output is just the input convolute with the impulse response. That's it. So you give me a system. You tell me the impulse response. Or I can find out no matter what. Then if you give me an input, I just do this convolution, I have the output. You give me another input, I still do this convolution, then I get the corresponding output. So I don't need to measure each one. So that is the significance of this convolution. But today we only need to know how to calculate this convolution. You need to know when you use convolution, but we also need to know how to get this convolution. Okay? So any questions on this? So we know how to do convolution, right? The homework is homework number 2 is practice this. Here it said, I will erase this. We said the output of LTI system is your input convolute with HT. HT is the impulse response. So impulse response HT. Let me ask again, what is HT? What is the impulse response? What is it? What's the meaning of this? Suppose I have a system here. That is LTI system. We only discussed this simple linear time invariant system. How do you find the impulse response of this system? For this system, you have an input, you have an output, right? What you do is you take the impulse as the input. You don't consider any other input. You only say, okay, the input is impulse. Let x equals delta. Then you find out the output. No matter you measure this or you calculate this, no matter how. This one is the impulse response. Is this clear? Right, now, clear or not? Okay, now I give you a quiz. If you're not clear, ask me questions. What is the impulse response? Understand this? That means you have a system here. I ask you, what is the impulse response? You just let the input equals the impulse, then the output will be the impulse response. It's good? So you have a system here, right? You have input, you are going to have output. That's that for sure. What is the impulse response? That means if your input is impulse, your output will be impulse response. Impulse response means the response to the impulse. As easy as this. Is it good? Okay, now I'll give you some fancy things. We discussed several systems, typical systems. Anyone can tell me one?
Linear system.
Yeah, linear system. Give me one example. How about delay? Time delay. Right? So for example, this system, if you have input here, then what is the output? Is t divided by some time. That is, we already proved before, this is a LTI system. So you give me input. What I do is I do not change the waveform, I only delay by some time, that's all. The signal transmit from through your system, no matter it's PCB board, the communication system, anything. Input is coming in. If you do not change anything, you just get exactly the same copy as the input, but you need to delay some time because the signal travel needs time, right? So you delay by some time. That is the simplest time ideal delay system. It's good? Okay. What is the impulse response to this? If you know this, I'll give you half bonus point.
What is it again? What's the impulse response?
This is ideal delay system. XT, you get this one is wrong, right? The YT will be equals to XT minus T sub 0, right? This one. Ideal delay by T sub 0. What is the impulse response?
XT minus T0.
I don't look at the notes. I let you preview the notes, but don't look at the notes. Anyone? What I said? How to get the impulse response? You make the input equals the impulse. Then the output is the impulse response.
So it's going to be x, t,
Minus T0.
Huh?
HT minus T0.
HT minus T0. HT minus T0. What is this? I'm asking this.
That's a response.
That's what response? What is it? What I want is, what is this HT? What is this? That is my question. What is this one, HT? You said this one equals HT minus T sub 0. What is HT?
X t minus t0.
What is x? For impulse response, there's no x. Yes, impulse. What else? T minus t sub 0. Good, you get half point.
You can say so.
Alright, so that's impulse. Why? Why this is correct? See, when the input is an impulse, what is your yt here? That will be impulse delayed by time, right? So this one will be t minus t sub 0. At this time, this yt will be equals to ht. See, that's right. This understandable? Eh? Look at the system. You give me xt, I give you a xt minus t0. That is the system. What is the impulse response? That means your xt is an impulse. What is your yt if the xt equals impulse? Impulse t minus t0. And what is that? That is xt, because your input is an impulse.
Okay.
Feel better?
Yeah.
Okay, now I give you one, no credit, no bonus point. How about this one? 2x. You just multiply by 2. This is a linear amplifier, right? Okay, so what is this system? What is this for this? 2 times impulse. Right? How did you get this? You replace x with impulse. As easy as this.
You may have a test on just this.
Is it good? Okay, now let's do another one. Right? This one here equals negative infinity to t and x tau d tau. This system. What is this? This is called an integrator, right? What if this one is an integrator? What is the impulse response?
Surely it's not just t.
Eh? Don't look at the notes. Eh? I give you the notes to let you read before the class. What's this? Okay, so the h tau, ht will be equal to, we just replace this x with the impulse, right? Right? So that is the idea, right? So negative infinity to t, the impulse, right? This d tau. What is the integration of the impulse?
Unit step.
Unit step, perfect. Half point. We discussed this, right?
Yeah, I forgot, yeah.
Integration get unit step. What is the integration of unit step? No point. What is it?
Unit ramp.
Ramp. Okay. What is the differentiation of ramp?
Will be steps.
Step. What's the differentiation of this one?
Impulse.
Input. Good for you. That's a reward for your review with the lecture notes. Integration of this one. So that means if this system is an integrator, that means the impulse response is just ut. Questions on this? Okay, now let me ask this. I tell you this one is the integrator, right? So you know the impulse response of this. So now if I said xt equals 3t, I say use 2t, right? Make this one. What is yt? you use the right way to do this from what we just discussed here. There are several ways to come to the right solution, but we use the way from here.
So are we using the integrator for that?
No, you use a convolution. So the input is 2t, that is a unit ramp, right? What is the output? I said this one here is just the integrator, right? Sure, you want to do this, do the integration of this 2t, 2 tau, d tau, right? You want to do this because this is integrator, right? I said don't use this method. Use the one I just told you. If you know this, I give you half point. What we should write after this equal sign?
Is it 2 impulse T?
2 impulse t? No, you use a step first. Sometimes a copy is good. And this is the time. That's the hint I give you. Anyone want to take this half point?
What say again?
I said sometimes the copy is good. And this is the time. Not copy that.
You don't need that.
I want the output of an LTI system. I give you the input. You know the impulse response, UT. What is the output?
UT.
2U2.
We already know how to do that thing. Now you need to know why we want to do that thing. What thing? Copy, copy, copy.
Well, that's the integration of T.
Don't think about integration. Right? No integration involved yet. The most significant concept here.
Look at my notes.
No, not on the notes. You look at the notes, nothing. Right?
It's not in the note.
Huh?
It's not in the note.
Yeah, you should know. I mentioned this several times. Why we want to discuss that technique? First one, we already used this example to show you can do that. Then, why you want to do that? Why it is useful? Here is the example. This is the LTI system. We know the impulse response, which is UT. And I tell you the input, I want the output. How to calculate the output? I count to 3, right?
RT.
I don't want the result. I want the method, how you do that. And by the way, RT is not correct.
Yeah, the impulse.
Is it gonna be, so you want the convolution for?
For what?
It's gonna be,
XT.
yeah. Shouldn't be XT.
Okay, you combine together, get this half point. Eh? I ask you to copy. It is here.
Yeah.
I give you the input. You know the impulse response. What I want is the output. And this is LTI system. So that one will be equals xt convolute with the t. So xt, so you can use 2t, convolute with, but better, you copy the formula first. xt convolute with xt.
Oh, it's gonna be XT convolute with UT?
Yes, so this one here will be equals 2t, right? So 2t, then convolute with
UT.
we already find out this by ourselves, right? So this one is UT.
Man.
Alright? Now you can do this, right? We already showed the example. So if you can do this, that is our output. And what is that output? We can directly calculate it because this is integral. So that result will be equals to t squared, tau squared sorry, 2 tau, 2 tau d tau, we assume from 0, from 0 to t, so that will be t squared. So somebody just mentioned it's called r. No, that's t squared. The integration of r, because this is r, right? The r integration, we get a quadratic form, polynomial, second order polynomial. Okay, any question on this? So you need to know how to do this convolution. First, we use the example to do that. Second, you need to know why you want to do the convolution. So this is useful, because this is a very useful tool. Question? Okay. Alright, now we just discuss some property of convolutions. Right? Suppose we have a system here, one system, and this one, the impulse response equals ht. This system can be time delay, can be integration, can be anything. Must be LTI. Alright, now I have another one here, and this one only the impulse response equals h2t. I will connect like this in series. Or it's called cascade. Right? So now I think consider this combination as one system. What is the impulse response of this combination? Huh? Okay, let's see. Suppose you have xt here. What is the output at this point? What is here? Yeah, yt. What is it? Xt convolute with this one, right? That is here, output for stage 1, but also the input of stage 2.
Yeah.
So this one here is xt convolute with h1t. That's at this point. What is the output at here? It will be the input of this convolute with h2, right? So that will be, the input is xt convolute with h1. That is the input to this one. And then convolute with h2t. Okay? It's good? And this one will be equals xt convolute with h1t convolute with h2t. So you can consider this combination as the input at the very beginning, then convolute with another one here. And this is the impulse response of the combination. Right? So that means this ht is convolute, this one convolute with h2t. Okay? It's good? That one is derivation. This one is the conclusion. Right? So if you have a series of systems, the total, the overall impulse response is the convolution for all these individual impulse responses. Good? Cannot hear you. Yes? Okay, this is the cascade. Alright, series. What's the next one? Parallel, yes. Okay, so we know where we are. Parallel. Parallel, that means we have xt here, and we have these two systems, and we combine together. This is the adder. So this one is h1t, this one is h2t. What do you think here? The yt. And I will consider this 2 as the combination. So what is the total HT, overall HT?
H1T plus H2.
Perfect. So this one will be H1 plus H2.
Half point.
Half point, yeah, half point. Okay, good. So that will be H1 plus H2. Why? Because what's the result here? This one is x times the convolute with H1 here. What's this one? This one will be x convolute with H2. Add up together, we use distributive. That one will be x convolute with H1 plus H2. So that's why this makes sense. Questions? Good? In the homework, we are going to test this. So I'll give you some like different impulse responses. So I ask you what is the impulse response of the cascade, what's the impulse response of the parallel, or something like this. Another property is, we know stable system, right? What is stable system?
Anything that's within its bound, basically.
If the output is bounded, right? But with the condition, if your input is bounded. Don't forget this. If your input is bounded, your output is bounded, then it's a stable system. If your input is not bounded, your output can not necessary to be bounded. So it's still a stable system, right? We know the impulse response represents the system itself. Right? Yes, I give you a system. What does that mean? I can give you the physical system. Hardware give it to you. Right? You have input, you measure the output by yourself, so you get that system. Or I can just give you a function, ht. You know how to use this, right? I give you input, you just do the convolution. You don't need to actually measure that. It's even better, right? So ht represents completely the system. Does it make sense? Okay, so let me test. I'll give you this one. Can you tell me what's this?
It's the impulse response.
I'll give you a system, this one. Can you tell me what is it?
It's the impulse response.
Hello, we just mentioned somewhere. Is this the integrator? Yes? See? I'll give you this one, then you know that box is the integrator. Right? If the system is stable, that means the sum, the integration of your h tau, absolute value d tau, must be bounded, must be equal to some constant a. This a cannot be equal to infinity, must be smaller than infinity. So this system is called stable system. Let me test it, right? The integrator. What is the impulse of the integrator? I just erase it.
UT.
Okay, equals ut. Is this system stable? Right? Now, don't look at this. We recall before. The integrator is stable or not?
Yes.
Yes? Okay, now let's check. The absolute value of this one is 1, right? You do the integration for all the range. Is this one bounded? What is the integration of this? What is the integration in this case? What's the integration of ut, u tau, d tau? What's this?
The unit rest.
Equals the ramp, equals RT. Is this one bounded? Is this one small or some number? Smaller than 1 million?
Yeah.
Oh. Are you sure? How about when t equals 1 million and 1? Is this one smaller than 1 billion? How about t equals 1 billion and 1? Eh? So this one is out of bound, unbounded. So that means this integration is unbounded. This A can be as large as I want. So that means this system is not stable. You forget that in the previous lectures, the integrator is not stable. It will accumulate all the result. If your time is big enough, that result can go to extreme. Can be as large as we want. So it's not stable. We proved from here. Okay, next, the next point for impulse is to solve the differential equation. We do not want to really solve differential equation, but from the last lectures we know LTI system can be represented by continuous time system can be represented by differential equations. So we need to solve, if we can solve the differential equations, then we solve the system. In mathematics, Math 280, you're going to learn how to solve differential equations. There are lots of ways, but the one way we are interested in is use this this way. So we use transform analysis. So I'll just give you an idea. We do not actually do this, at least right now. Okay, so. Okay, that's it for today. Any questions on it? I posted the lecture notes, and the purpose is for you to read before the lecture, review after the lecture. Okay, thanks.
Still with the homework?
The homework is due now, yes.